Hello, everybody, and welcome to our second day of class, which is obviously remote due to the snow. Today, we're going to be learning about, introducing trigonometry. So this is a topic that we definitely want to pay close attention to. There are thousands of videos out there kind of introducing these. So if somehow this doesn't do it justice, or if you have some follow-up questions or are struggling to complete the accompanying worksheet, it's definitely going to be good to start off on the wrong foot with these. So the warm-up we had done in class, just to kind of reiterate if somebody didn't quite catch it, we're going to find this missing length here, y, and then use that in this basically follow-up triangle. So we have y, 8, and x is our hypotenuse of another right triangle. So that was our warm-up, but again, we had focused on it in class for the most part. And that segues into what's different about this triangle that prevents us from using the Pythagorean theorem? And what we end up finding is that I have one leg, but really that's about it. I do have an angle, which is nice, and that's going to help us be able to apply trig to it, but I don't have anything else, so I can't do Pythagorean theorem as much as I would like to. So then we introduce trig. And essentially what it's going to mean is basically in this 37-degree triangle, or in any right triangle that has this 37 degrees in it, there's going to be a relationship between the hypotenuse and the adjacent side, or the hypotenuse and the opposite side. So even if I had this triangle and made it bigger or smaller, the ratio between those sides has to stay the same. Okay? So let's look at kind of a particular case here where I'm going to have theta kind of in the bottom right of this triangle, and then I'm going to label my sides of this triangle. So this side that is opposite of theta, I will be calling the opposite side. Sometimes we're just going to shorten that to OPP, and just to kind of help us out. My hypotenuse, the vocabulary on that is not changing with trig, so this is still my hypotenuse. And then this side that is next to my theta, I am going to call the adjacent side. Adjacent meaning next to. The line that I've kind of drawn from theta to opposite generally helps me identify what is my opposite side. From there, I know that the hypotenuse is across from the 90 degrees, and then my third side is just going to be my adjacent side. So folks, if we get to the point of practicing this and we start struggling, that's going to be kind of helpful for us. And trig, to introduce them, we have three trig expressions that we're going to learn kind of first, and we'll learn some other ones later on this year, but we end up with sine, cosine, and tangent. So these are the three-letter abbreviations for those. So sine is normally, sine has an E on the end of it, cosine is co and then sine, and then tangent normally has GENT on the end of it, but we're going to keep it to the calculator shorthand that we have. And what my calculator can do is if I feed sine an angle, or if I say, hey, calculator, find the sine of 30 degrees, it's going to tell me the ratio of the opposite side divided by the hypotenuse, okay, because that's going to be a fixed value. So depending on the angle that I give it, I would literally type into my calculator sine 58 and then hit enter, and it's going to spit out some value. So just as an example, if I actually type that in, I end up getting this 0.848. And what that means is in a right triangle, and if one of my angles is 58 degrees, particularly this angle in this case, which is also known as my reference angle, then it's going to tell me that the opposite divided by the hypotenuse in that triangle is 0.848. That is the ratio between those two. And at first glance, we might still be kind of confused as to how we're going to be using this, but once we get into some examples, it should make a little bit more sense. So similarly, cosine is going to tell us the ratio of two sides in this. So if I were to feed cosine an angle, it's going to spit out the ratio of the adjacent side to the hypotenuse. And finally, tangent is going to cover the other combination, which is opposite over adjacent. So these really need to be memorized. So knowing that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent is something that we're going to need to know. Sometimes folks will use this, mnemonic device in order to come up with it, but it's so ka toa. And if we take a look at kind of what we have here, it's saying that sine is opposite divided by hypotenuse. So it basically keeps that order as well. So cosine is adjacent divided by hypotenuse. Tangent is opposite divided by adjacent. So ka toa. And that's something that I'll probably be saying in class if we ever start forgetting these, but that is the basics of it. So let's go back to this problem up top that I was unable to do a moment ago and see how Trig is going to help me figure these out. So the orientation of my triangle has changed a little, but what I might do to start is, given that reference angle 37 degrees, I might just label these sides. So this is my opposite, this is my adjacent, and this is my hypotenuse. And what I'm looking to do is find my hypotenuse, and I've been given the adjacent side. So I have my choice of 3 different trig expressions, but I want to choose the one that relates an angle, adjacent, and hypotenuse. So that is going to be cosine that I'm going to use in this particular case. Because if we look at what cosine needs, or kind of what's in the recipe, it needs to be given an angle, it needs to be given either an adjacent or a hypotenuse. So in this case, even though I'm missing one of those values, it's still going to give me a partially complete equation that I can solve, versus, if I did sine, then I have opposite and hypotenuse, and I don't know either of those. And if I had used tangent, opposite, and adjacent, I have the adjacent, but I'm not looking for the opposite, so it's really not helpful. So I'm going to say, okay, I'm going to use cosine here. And I'm going to say that the cosine of 37 degrees is going to be equal to the adjacent divided by the hypotenuse. So that's 11 divided by x. Okay, and this becomes an equation that's not like super straightforward to solve, but what I would encourage you to do right now is just kind of a calculator check, because I said that some of these are going to spit out some values that were not 100%. We don't know if they're right or wrong until we compare with this. So when you type in cosine of 37 into whatever device that you have, we should be getting 0.798, and I'm going to say 6. I'm going to go out one more kind of decimal spot there. So if you're not getting that, there's probably an adjustment that needs to be made to your calculator, or a setting, or your phone needs to have a certain button pushed right away. But that is what we should get when we do that. Now, we still have this equation where we might still be struggling to think about how we're going to solve this, but I'll show us kind of the long route, and then I'll show us the shortcut that we're going to take from now on. So the longer route is to say, well, I really don't want this x in the denominator, so I'm going to multiply by x on both sides. When I multiply by x, this side's just going to become 11, and this side's going to become 0.7986 x. Now I'm staring at this, so I'm going to divide both sides by 0.7986. And if I rewrite this up here, now I have x equals, so I'm going to type this into my calculator, see what I get. So I am at 13.773 for my x. So my hypotenuse here should be 13.773. Checking the reasonableness of this, my hypotenuse is larger than my adjacent, which is expected. My hypotenuse should always be the longest side. So I'm pretty happy with that. That seems like a reasonable answer. And, the shortcut that I had talked about was recognizing that really when I'm in this case, I can just swap these two values. Okay, so if the thing that I'm solving for is in my denominator, it's a little bit annoying to take these two steps to multiply by x and divide by 0.7986. So the shortcut that we're just going to take in the future is to just literally swap them out. It just saves us a little bit of time and that understanding. So we can just say, oh, okay, well, that's just going to be 11 divided by 0.7986, which tells us our answer. All right, so we use one trig function and we had, a solving strategy that we had to do, but let's take a look at some of the other examples. I think I was going to do about 3 together. We'll see if that's enough. There's a word problem associated with it also, but I'll kind of gauge that as we go along here. All right, so step 1, what I'm going to encourage us to do again is to label these sides. So I have opposite and hypotenuse are really the ones that I care about. I do have adjacent down here, but I'm mostly just stressing the fact that opposite and hypotenuse are the ones that I want. So if I have this, so ka toa, I want to use sine, okay, because I'm looking for the relationship between the opposite and the hypotenuse. I don't care about adjacent. I'm not looking for it, and I don't know it, so I don't want to use cosine or tangent. So I'm thinking, all right, I'm supposed to use sine. And I know that the sine of my angle is going to equal the opposite divided by the hypotenuse. So I end up with 20 over x. Here's our situation where the thing that I'm solving for is in the denominator. So I'm just going to go for a straight up swap between x and sine of 28. So now I have x equals 20 divided by the sine of 28. You'll notice here also I didn't simplify sine of 28 first, and that's because if I can hold out for as long as possible, like all the way until the end, then I know that I'm going to be as accurate as I can be. As soon as we switch sine of 28 to some big ugly decimal, it's going to just become more and more ugly. So now I have 20 divided by the sine of 28, which I'm punching into my calculator. I got 42.6. So my hypotenuse is 42.6. Looking at it, seems reasonable, happy enough with it to move on to the next question here. So let me see, there's that one. So I'm going to swap this one on you, so just kind of pay attention to this first. I'm going to make it so that the adjacent side is what I am looking for. So I'm just kind of completely changing that question. So make sure that you redraw those numbers on your own triangle, otherwise this isn't going to make a lot of sense. And I'll let you know why I did that in a second. But labeling my sides, opposite my angle, my hypotenuse is across from the right angle. This is my adjacent side. So I want a trig function that relates hypotenuse and adjacent. So looking back at so ka toa, I can see that that is going to be cosine. And then I'm just going to try writing my equation and see where I'm at. So I have cosine of my reference angle, or 48 degrees, is going to equal x over 18. So we might see here kind of why I made that swap was in this case, the value that I'm looking for is in the numerator. So I don't want to overcomplicate this. In order to solve for x here, x is being divided by 18. So I'm just going to multiply both sides by 18. So I get 18 times the cosine of 48 equals x. So it's a little bit more straightforward. Some people are going to confuse that with the earlier strategy of the straight up swap, but I wanted to cover both instances here. So that's going to equal 12.044. It's less than my hypotenuse, so I am happy with it. It's what I would pretty much expect. Again, if you get something like 19 or 20 or 2 or 3, like any of those should kind of cause you to pause and rethink what you're doing and how it's going. All right, 70 degrees, labeling my sides, opposite, hypotenuse, adjacent. So I don't care about my hypotenuse. So sine and cosine are out because those are used in those trig functions. But I do have tangent here. So I know that the tangent of 70 degrees is equal to the opposite divided by adjacent. So that would be 19 over x. I'm again in a situation where the variable I want to solve for is in the denominator. So I'm going to do just a strict swap between those two. If we don't like doing that, multiply by x and divide by tangent of 70. Obviously, we're going to get to this same step here. Punch that into my calculator. Should arrive at a value of 6.915 down here. Seems about right. No qualms, ready to move on with those. So those are the three kind of different examples, right? Our trig function is going to change, as well as potentially our solving strategy. So if you need to come back to this, know that really here were the two distinct solving strategies. So at one point we need to, if the variable I'm looking to solve for is in the denominator, then I traditionally am just going to swap locations with the left-hand side. And then if the variable that I'm looking to solve for is already in my numerator, then I just need to clear that denominator or multiply by whatever that denominator is in order to take care of that. So let's do one word problem, and then I'll leave you to your practice. So we have a ladder leaning against a building. Here we go. Makes an angle of 78 degrees with the ground. The foot of the ladder is 5 feet from the building. How long is the ladder? So very common question. We actually examine this a lot, even in calculus. We could say, how high on the building does this ladder go versus how long is the ladder? But in this case, we're just looking for the length of that ladder. So if I'm labeling my sides, this is my opposite side, this is my adjacent side, this is hypotenuse. I'm looking to relate adjacent and hypotenuse, which is cosine. So I can say that the cosine of 78 degrees equals 5 over x. Lots of situations here where my variable's in the denominator, for good or for worse. So I'm going to be doing just a quick switch of the x and the cosine here, getting this, and then punching it into my calculator. So I get a ladder that is 24.048, looks like feet tall. And that could make sense. So I've got this 24.048. My 78 degrees probably isn't quite exaggerated enough here to really kind of get the full scope of this, but that is going to be the length of my ladder. All right, so there are a number of trig questions I think that I had attached in a worksheet, and my goal would be for you to complete 10 of those problems, so of your choosing, and I'll try to even, let's see, I don't know that I'll be able to get the answers up before Thursday until I get back into the classroom because I'm not entirely sure the exact worksheet that I had printed out for you. And then you'll notice on the calendar that I also put some challenge questions. So if you're flying through this, not being kind of faced with that struggle that I hope I can provide all students, then I would take a look at those challenge problems and see how they look if you have any questions with them. All right, thanks folks for the flexibility on the snow day, and